now we have learned how to use table and t-apply, right? So we can actually, we learned that by using these two simple functions, we can answer a lot of questions, right? A lot of questions. Now let's put it to use, okay? What is that for, right? We look into the proportion of bad guys in eye color. What is it useful? Why is that useful, right? So now, before that, let's kind of like review the last two questions in the Kahoot. Okay, the last two questions is the number and proportion of bad in each eye color, right? So and we do it in t-apply. Okay. Now if I change the question, right, from the number proportion of eye color within bed, okay. This is the number and proportion of bed in each eye color, right? Now I change these two things. I change the two categorical variable, right? Bed is a category, right? Within a line, right? And eye color is actually there are a lot of eye colors, right? So if I try to answer this question by t-apply, there will be a problem, right? Okay, if I put the di here, right? The I has to equal to some color, isn't it? Right? Okay. So say if I do a t-apply like this, I'll get an answer. The answer would not be what we need. If I try to answer this question by t-apply, then I right. Well, it would not work, right? Because I will have to do it like this. So, which means that with this command, I'm counting, right? I'm counting within each line, the number of blue eye, right? So if I want to do it by t-apply for all of the eye colors, I need to type a lot of eye colors, isn't it? Right? See, if I want to answer this question with t-apply, now it's very inconvenient, isn't it? Okay. Because when I'm using t-apply, I need to have the eye color specified, right? And each line of code, I can only look into one eye color, right? It's too specific, right? Okay. So in this case, to answer a question like this, we might want to subset, right? We use this subset to choose all of the bad guys into a new data frame called bad. Okay? See, if the question is too complicated and you cannot answer it by one line of code, right? Okay, you can always like divide and conquer, right? Try to like do it in two steps, right? Yes?
Professor, here what I did was I used t-apply.
Yes.
D dollar align equals to bad, comma D dollar I, comma sum, and I still got the same answer as yours.
You using
T-apply to get the same answer. D dollar align equal to bad, comma D dollar I, comma sum.
Oh, I know what you mean. equal to bad.
Yes. D dollar I. Professor, the spelling of bad. B-A-D.
Okay.
Same.
So you are saying that you are getting the same number? What?
Yes, Professor. Same answer. With the. Yeah.
But they are different though. The blue color bad guy is A37. That's correct. But
Professor, we were talking. Sorry. Are we talking about the question, the numbers, proportions of eye colors within bad guys? Yes. Yes.
yeah, I'm doing this. I'm doing this. But this one is for it's kind of like this one, right?
But Professor, in the HTML,
In-
answers to both those questions are the same,
Let me see.
exact same. Like the final answer, not the formula. The final answer is the exact same.
Yeah, you mean that this one is the same as this one, right?
Yes.
Right?
So, how is it different?
They are the same. They should be the same, right?
Okay.
Isn't it? If you count the number of bad guy in each eye color, right? And in this one, I do it in different way, right? First of all, I select all of the bad guy into this data frame called bad,
Okay, sorry,
right?
got
And I do table on the bad, right? So I basically kind of like collect all of the bad guys into this data frame, right? And then I count the eye color in the bad guys. So I should have the same number as this one, right?
So, you are just showing us different ways to get to the
Yeah, yeah. And these two questions, right, the questions are different, right? Here we are talking about the numbers of bad in each eye color. And here we are talking about the number of eye colors within bad guy. But they should be the same number, right? Okay? If you doing the count, okay, and you like kind of like switch the categorical variable, the count is the same, right? Okay? Because there's always like A37 blue eye bad guys, right? They are always A37 blue color bad guys. The numbers should be the same. If you are using the count, the order of this categorical variable does not matter, right? However, if we are talking about proportion, it'll be different. Okay? Here in the Kahoot, we are doing the proportion of bad in each eye color, right? So this is the proportion of bad in black eye, in blue eye, in brown eye, right? This is one thing. But if we are doing the proportion of eye color in bad guys, okay? So you get something like this, right? This is the probability of eye color, the distribution of eye color within bad guys, okay? So this proportion are very different from this one. Can you tell the difference? And why? When I ask the proportion of eye color within bad guys, all of this, the proportion should add up to 1, right? Because within bad guy, I'm talking about the proportion of eye color, right? And this one is different. Within each eye color, I'm talking about the probability, the proportion of bad guy, right? So this is the proportion of eye color, and this is the proportion of bad guy, okay? So the proportion will be different, okay? And this is the idea of like, let's before going any further, like let's do a quiz, okay? By team, right? I want you to discuss, right? What is the most likely eye color within bad guy? which one should you use? Should you use this one or this one to answer what is the most likely eye color within bad guy?
Second one, property.
Second one, right? Anyone have the different answer? No, huh? Right, second one is right? Because we are talking about what is the most likely eye color. I'm talking about the probability of eye colors within bad guys, right? So should be this one. Now, what eye color is most likely to be bad? Red color is most likely to be bad? How did you get the answer? By looking at this, right? Okay. Now, given eye colors, this number is actually the probability of bad, right? So when we are asking the most likely, which eye color is most likely to be bad, we are asking the maximum here, right? So it's red eye, okay? Isn't it? Now let's put that to use, right? Discuss within your group, okay? And when you have an answer, like raise your hand, okay? So if we wanted to identify bad guys by eye color, which question should we ask? If we want to identify bad guy by looking at their eye color, right? Then which answer should we ask? Sorry, there's a typo here. I want to identify bad guys by looking at, which means that given the eye color, right? Given the eye color, I want to pick out the bad guys. So what is the right question should I ask? The fourth one? Any other answer? The other answer is 2 and 4. Okay. Okay, but let's look into the so let's work it out together. Okay. So I want to identify bad guys by their eye color, right? So given eye color, I want to know the probability of bad guys, right? So when I see a blue eye, so I want to see that the probability of bad. If I see a red eye, I want to see its probability of bad, right? So the correct answer is this one, right? Isn't it? Right? Because when I do this one, I actually see the probability of being bad, given eye color, right? So this is what we mean by conditional probability, right? Given eye color, I want to know the probability of bad. because I want to identify bad guys, right? So I want to know the probability of being bad by eye color, right? Okay, so categorical proportion is actually conditional probability, right? So using conditional probability, you can make a lot of business decision. Okay? I know that you feel like confused, right? You feel like dizzy. It's normal, right? And during the course, I will give you a lot of data cases. So you will use these things again, and again in the business context, right? Okay? So, yeah.
Professor, why can't it be 2 as well?
Oh, why can't it be 2 as well? So if you look into 2, right? It's the number of bad guy within each eye color, right? So it's this one, right? Right? The number of bad guys within sorry, the numbers of eye color within bad guys. And 2 is the number of bad guys within each eye color. It's actually the same thing, right?
2 and 4 are the same? Or
I mean, the 1 and 2, they will get the same answer, right? You see this one, and you see this one, right? Now, this is the number of bad guy in each eye color. You see that? The number of bad guys in each eye color, right? Now, the number of bad guys in each eye color, if you look into here, you will see that blue eye has the largest number of bad guys, right? But can we tell that, see, the blue guy only have a 28% of being bad, right? Why? It has the largest number of bad, right? But it do not have a, within that eye color, it only have a 28% of them are bad guys, which means that there are a lot of blue eye characters. So only by looking into the numbers, you cannot see the probability, right? Because probability is a proportion, right? There is a denominator, right? Isn't it? So if you are looking about the most likely, if you are asking about probability, you are asking about the proportion, right? And when you want to do proportion, you want to do the denominator. What is the best, right? What is the best line, right? So, yes, there are a lot of blue eye bad guys, okay? But there are a lot of blue eye character in the population, right? Maybe there are more blue eye good guys, right? Simply because they are a lot, simply comparing the numbers, simply comparing the count cannot answer the question of probability, right? When we want to identify something, right, we are talking about something like this, right? Given the eye color, I want to know the probability, right, of bad, right? Okay? So if I ask the question the other way, given bad, I want to know the probability of each eye color, right? So given bad guys, okay, I would like to see the probability of this is the they will give us a different answer, isn't it? Right? Okay. So when you do the categorical proportion, right? The key thing is you need to ask the right question, right? Okay. Yeah.
in the last table, the table that is $I, if we add all the numbers, it will give us 1.
Right.
So that 1 is equal to the total number of bad guys. What does that 1 number signify? The total, what does it signify? Does it mean it gives you the total number of bad guys?
If you want to know the total number of bad guys, you should add this number, right?
So when we add the proportions,
Yeah.
it will always it will be equal to 1.
Right. The reason that it would always equal to 1 is the proportion is actually, if we sum this, right, it's the total number of bad guys, right? So you use the total number of bad guys as the denominator,
Yes.
right? So because the denominator is the sum, right? So if you add them up, they would equal to 1, right? That's the logic, right? Okay. So if we want to put the now we already learned how to calculate, how to do count, how to do categorical count, right? And how to do proportion, how to do categorical proportion, okay? But when we put that to practical business context, okay? The most important things, you need to be able to ask the correct answer, the correct question, right? Otherwise, you were like, if you only know how to write programs, it would not be useful at all, right? So everything starts with asking the right question, right? So you can determine which of these things that you want to use, right? I know that's still confusing right now, right? And there's no easy way to like learn it in one shot, okay? So as I concluded here, now table or t-apply are literally the most powerful function in R, okay? I can tell you that if you can use this, you can solve like 70, maybe 80% of the business question already, okay? But you need to use it in the right way, right? It's not easy, okay? To use it in the right way is not easy because it looks very simple, but they are very flexible, right? So this simple and flexible is a characteristic of programming language, right? Language starts with a very simple grammar, right? But you can use it to express whatever you want to express, right? That's what programming really about. Okay, so so combining with indexing, you actually can use to compare virtually everything, right? You can actually compare virtually everything. But it takes practice and exercise to and experience to build your fluency, right? To build fluency. Another important thing to learn is that proportion imply probability, right? Okay, so and categorical proportion imply conditional probability. See that? Okay. And with conditional probability, with this categorical proportion, we actually can make business decision, right? Okay, right. So if you are a policeman, you want to identify bad guy with their eye color, right? So you can use the virtually the same thing, right? Okay. So it helps us to do prediction and help us to do decision making. Okay. So right now is the 4th week of our class, right? So after learning some basic programming, okay, I'm trying to add in some concept of simple probability, okay, and try to by comparing the probability, by comparing the counts, it will help us in managerial practice. Get it? Okay. That's what we want to do in this class. Okay. And I want to do it in a way that I will give you data case after data case after data case, something like this. Okay. and you will try to like learn these basic things, right? And get familiar with these basic things in this course. Okay, that's our objectives. Any question up to this point of time? No, huh? Okay, good. Now, let's go back to the notebook of two C. Okay. Unit 2C, okay? Go to I think we are here, right? Okay. Now, because of we are behind the schedule already, right? So for the rest of the there are still some content here. I'll go through this content very briefly. Okay. Now sometimes we want to know the trend. Okay. So if we want to know the trend, we will need to use a line plot. For example, this is the if I add a new column called decade, okay. So I actually use the year and use this operator to combine it into decade, okay. And then you can see that the number of new character in each decade, it's the 30s, 40s, 50s, right, to the 90s and 2000, 2001, okay.
Professor, what does an operator mean?
It means when you do the divide, right, you only take the integer part,
Yes.
okay.
Yes.
Just ignore the everything after the decimal point, okay. That's what it means, okay. So because I want to turn it into like decades, right, so that's the way I do it. So if I do a t-apply, I can actually see the fraction of neutral character by decades, right? See, and then you can see the trend, right? Okay, the fraction of neutral character by decades, 7%, 9%, and like this 18%, right? Back to 18% again, right? But if you only look into this number, yes, you can see the exact number, but you cannot see the trend, right? Okay, so from time to time, you would like to like kind of like make a plot, okay? So if I do a bar plot, okay, I can do it like this, right? This is the proportion of neutral, right, character in each decade. So you can see the trend here. It's the upward trend, and going down in the 80s, and then the upward again. See? Right? In R, you can plot it in a lot of different ways. Okay? You can plot it by bar plot. V is actually this vector, right? Okay? This vector is V. So if I directly put V into a bar plot, I'll see this one. Okay? Now if I plot V and which means if I can actually plot a line plot, okay? And line plot is two-dimensional, right? I have the x-axis and the y-axis. In the x-axis is here, the name of V. Name of V is actually this, right? 3, 4, 5, 6, 7, right? So I use the name of V as the x-axis, and I use the value of V as the y, right? So you can see a line plot, right? So if you want to, if you use plot and give the x and y value, by default, it will produce a line plot. Sorry, by default, it will produce a scatter plot like this. Okay, if you just give it a name and then the value, this is the x and y, right? X and y pair, then you will like actually put a mark on each of these x and y pair. Okay, in order to see the plan, sometimes you would like to use this type equal to L. If you use type equal to L, then you will generate a line plot like this. Okay, and then if you want to like put these two things together, right? It's a line plot with a marker in every data point, right? So this is, you can use type B, okay? And then this y limit is just to choose the limitation, right? Choose the scale of the y limit. Okay. So I just want to give you some idea about how we can visualize the data to see the trend. Okay. Okay. This is another thing that could be very useful in the business context, right? And in R, in order to visualize the data, there is a function called plot. Okay. And with plot, you can give it the x and y value of every data point. And then the x and y value of the data point will be plotted in a scatter plot. Okay. If you want a line plot, you need to add an argument called type equal to L, stand for line, right? If you want to have a marker on the line plot, instead of using L, you use the type of B, right? Okay. So we will go back to these things later on. So I just want to like cover it before concluding this comic data set. Okay. Now we spend about 4 or 5 hours in this comic data set because this is the first data set we are looking into in depth. Okay. And for the rest of the time today, I would like to like show you 3 more cases. Okay. The 3 cases. Last week I asked you to see a YouTube, right? How many of them have already watched the YouTube playlist? Some of them had already see the YouTube playlist, huh? Some of them have not. But the rest of the time today, I would like to do this. Okay. We are going into like Unit 3, okay? And in Unit 3, I have like 3 data cases, okay? Real data cases. Now, the first one is called Digital Detective. The second one is stock price. And the third one is like census data, okay? These are the real cases, okay? That I quoted from the online course. I cited from the online course from the MIT Sloan Business School, right? Massachusetts Institution of Technology, right? This is the first class school, the first class business school, right? So the data set are given in AS31, 32, and 333. Okay, so you can get the data set by go to Unit 3. Now this is Unit 3 and 4. Okay, so we are talking about these 3 notebooks. Okay, and the notebook and data can be can be acquired here. No, it's 2. I should go to Unit 3, okay? Go to Unit 3, and then you will see that, sorry, here should be Unit 3, okay? So you will see a PowerPoint and also a zip file, right? Now again, download this zip file, right? And unzip the file. Then you will see something like, in your PC, you should have something like this. Okay, you download the zip file, and within the zip file there's a folder, right? 03. Just pull the folder into, right? IB533. Then you will see a new folder, right? 03. And then go to your RStudio, and you actually can go to here, right? I mean, go to 03 and then open it, and you will see the HTML and RMD file here, okay? So these cases are actually a real business case, okay? You use this data to do some managerial, they have some managerial implication behind this data, right? So we are using the coming database for fun, right? But now let's start to do business, okay? So let's start to do some managerial type of things. So this 3 data case, I'd like you to, using the programming technique that I already told you, right? I want you to, like, in this week, I will give you a in this week, I will give you a team assignment, okay? There is a personal assignment, right? Just 2C things, right? You just annotate this 2C and compile put your note into this 2C, right? And then it's a very lengthy notebook by itself, right? So finish it. Try to answer the question with some code chunk, right, below the question, and then that is your personal assignment for this week, okay? So you can, like, finish it and change the file name of the HTML with your student ID, okay, and then upload it here.
Sorry, can you please repeat? So in 2C we have to do from the 6th point afterwards? Like the questions that we just discussed today, we just have to write them down?
Well, it's up to you. I just want you guys to, like, walk through just take another look at this this notebook and knit it into HTML and, like, use it as your notebook. Just try to write some note in the notebook and then submit your notebook, okay? This is your personal team assignment. And then we will have a group assignment, okay? That group assignment is that I want you to, like, watch the YouTube playlist, okay? In this playlist, I will have the instruction, okay, about how to work on these 3 notebooks, okay? And then for each of these 3 notebooks, as you can see here, let me do some cleanup, okay? Now, if you look into this notebook, you will see that they are some of the code chunk has already have code, right? And some code chunk are actually this is the question I left for you. Okay, in your team assignment, you will need to like write the code to answer this question. Okay, just replace this remark, replace this remark with the code that used to answer this question. Okay, you can see that, right? So A, B, C, they are all the same, right? There are some like 10, 20 questions in each of this data set. I will walk you through this data set one by one in the next hour, okay? And then it will be your team homework assignment, right? To like go into this notebook. For example, like the stock line. See, there are a lot of things you need to do, right? Okay? And finish this and knit the assignment notebook and then upload it into the group folder, okay? And 1期, actually, when you finish your team assignment, right, you need to upload it, okay? So today there's a thing very important. You need to go to 1期and you need to tell 1期your Gmail account, right? So it can give you the permission to upload your file. So actually here, there's a folder called team, okay? So they are groups. And then within the group, this is where you upload your data, okay? And only the team member can access the folder, okay? So you need to give 1期your Gmail account so you can assign the permission for you to upload your team assignment, okay? So for team assignment, you only need to do once per team, okay? Got it? Okay, so for the rest of the time, I will walk you through the data and maybe teach you some technique. Most of the technique you already learned, right? You will see that how powerful table and tier apply is, right? Because you will use table and tier apply again, and again. And you will see that most of the question can be answered by this table and tier apply. Okay? And there are some more things I haven't told you yet. And I will spend the rest of today's class to walk you through this 3 data set and talk about some of the thing that you will need in order to finish these things. Okay? Good. It's 10:59. Let's take a 10 minutes break. And let's be back in 11:10. Okay? Be punctual because otherwise we might run after 12 o'clock today. Okay?